This conference will now be recorded.
Hey Shab, if you want me to get started, I can also get started until you get more of a quorum, because I think I really want feedback from you guys. You, Ken, Elad, and Mark on the changes I've made.
Sure. I put you on the basically item number 1 and number 2, Wapi. If you want, I can say what do we have for today agenda,
Yeah.
and then you can start. I think first is that your update from adapter group to check if there is a error correction over there or not, because that's going to actually affect the discussion that we have later today for bit error rate requirement. Then Wapi is going to be on second, again, some update on the first part of the spec. Then the third item in our list is continuing discussion on proposal to change the bit error rate from 1e to the power of -15 to -18, and also list of the open items for finalizing the spec, which so far I only received from Ila. If there is anything else or something that you guys want to add to today's agenda, let me know. Otherwise, we're gonna proceed with this order.
So we have... not that we have to cover it today, but one thing I wanted to add to our agenda, as I was going through the spec, trying to see if I could find any items that we needed to close, I realized that just at the beginning of the spec is probably our biggest, most difficult thing to close, which is the CLA. I think we probably, if we really want to go and release this, are going to have to reopen that up and start making progress towards finding a CLA that's acceptable to the folks who are contributing.
Very
well.
We're
going to reserve the month of July for the CLA, or the month of August. I'm kidding.
Well, I guess I'm thinking that when we went through this quite some time ago, for the initial spec, our lawyers took quite some time iterating on the CLA. So yep. I think it's something that we should definitely figure out. And I don't know, Boppy, if you've heard anything recently on whether anybody like the Open HBI group has been able to make progress with the documentation they're using to agree on.
So per Ken, they've all sort of synced on the CLA, so we should be able to
steal that.
Yeah.
Okay, to save time, if everybody agree, Mark, do you want to do it right now, because you already covered it in half?
Oh no, we won't save time. Trust me.
No, yeah. It's a can of worms. I guess if I could just ask whoever might be able to share a copy of it to reach out and kind of provide one for folks to mull over. That would be great, and then we can kind of shelf this for today, because Bobby's right. We'll spend all day on it.
Okay.
So another topic is that there are some things pointed out in the bump patterns by the BO test chip group, that some things that we ought to change in the recommended diagrams.
Hey Shab, as a standing order, could we please spend the last 5 minutes figuring out the agenda for the next meeting, so that we're not caught off guard?
What I usually do is in the minute that it's shared with everyone, I believe, I have basically two lines. One is actually that I'm keeping the record of the today's meeting, and anything that you guys want, I will basically add to the next week agenda.
Sounds like a plan.
Buffy, I have one more question about the termination. Is this a good time to talk about it, or should I wait?
Can we just add it to the end of the? If it's could we just add it to the agenda item, or you think it's important that we hit it up front?
I think we can wait until the end. Yeah.
There might. I don't know if. Maybe super quickly, because there was a discussion we had, and I don't recall if you were there for that one, where I believe there was agreement to make it so the termination the termination can be kind of to whichever voltage the receiver chooses to terminate it to. I believe that was agreed to. I don't know if that has been updated in the spec yet. Would that cover what you were thinking of, or it's something else?
Oh, that's more or less I'm thinking about it. Right now, the spec says it's Thevenin equivalent, so it's going to change VAL, VAH.
Yeah, basically. So I think, and others should correct me if my recollection is wrong, but I think we also sort of brought up that we thought that was not necessarily the most flexible or overall best choice. So I believe there was agreement to change it so that the receiver can just terminate it to wherever they want to. And so the swing is specified, but what the actual level seen at the receiver would obviously depend on where you terminate to. Does that make sense? Or?
Yeah. That's what we, I think, discussed and we agreed on a couple of weeks ago.
Great.
Thanks a lot. That's what is in my mind.
Great. Okay. Good. We knocked one thing off, without doing anything.
And are we going to update the spec based on that, or what is that?
I believe so, yes. So I don't know, unfortunately, I don't know who had the action item to actually do the update. So that's I had sent, to Bapi and Shahab kind of a list of things that I was tracking that were quote unquote opens that may have been updated in latest versions of the spec already without me necessarily knowing about it. So that's definitely something we should check on.
Okay.
Yeah, so I can add that to the spec.
Great.
But
Okay, Bapi,
you should be able to add stuff too. If you just check it out and you add stuff to the spec if you'd like.
Okay, yeah, sure. No, I just I wasn't quite sure kind of what the standard practice for folks was in terms of if there's one person who's kind of doing master branch things now and we want to hold off or we want to just sort of have a bunch of merge requests and yeah.
Okay, Bapi,
Okay.
do you want to go ahead on your two items?
Yep, I can go.
First, if you can update us on the error correction and then a spec update.
Can you see my screen?
We do.
Okay, miracle. I started maintaining minutes. Who's taking minutes today?
Yeah, I'm taking, don't worry.
Okay. Anyway, so yes, there are coding options. So roughly this, you can see my notes from the link layer meeting on 6.3. This is what we this is what we are agreeing on as a starting point. That we're looking at three options: none, weak detection, strong correction, and we're trying to figure out whether retry is optional or just not specified at all and pushed to the transaction layer. That roughly this is the starting problem statement for error correction and coding. That's basically my summary.
So it seems like retry is a higher layer thing.
Well, that's there's some debate on that. The question is, do you mention it and say it's optional, or do you not specify it at all, or still up in the air?
I guess I didn't think it was relevant to a phi level at all.
Well, if you look at PCIe, say for example, there's a retry at the transaction level, right? I think.
Yeah, PCI agency.
Yeah. So,
Right,
so do you want to make
if-
retry a link layer function or a transaction layer function? Is the
right, but it's not part of phi either way.
No, I thought the question from you guys was, hey, is the link layer going to do error detection and correction? And so
I see. Okay.
Sorry, can anyone comment and basically teach me? Is there any difference between retry and replay?
Retry. I don't know.
Replay sounds like it's.
I don't think there's a strong difference. I think it's just nomenclature for PCI Express.
Okay, because there was basically, I think neither Dave and John are not on the call today, but there was an announcement by Synopsys last week that they are trying to do replay. I wasn't sure by replaying. My assumption was that it's a retry, but I wanted to just double check.
Yeah, my understanding is that replay is the PCI Express version of retry.
Okay. Thanks.
So that's basically the status. So I think the
Uh,
short
this-
answer, the brief answer is yes. Retry is error correction and link reliability is a part of the link layer.
Where was the link layer team on mandating detection? I'm curious how that would impact us at the PHY level. Would that mean that there would be encoding that's kind of built into the data stream like PCI Express, or would that kind of mandate the use of the FEC bit? What is the thinking on how that would be implemented?
It's the thinking is that it will most likely you reuse the CXL flit structure, and the question is, do we need permission or can we just reuse it? And that flit has, in general, the flit has some room for an error detecting code as a part of the flit itself.
Flit is
So-
like a packet.
It is the same retry as CXL. Basically, it's get adopted from the PCI Gen 6, if I remember correctly.
No, not the retry part, just the flit structure. So they're two different things, right? So a flit will have some room in its structure for an error detecting code, kind of like a checksum code in an IP packet or something. And so in that case, that the PHY's FEC bit would basically be a way of raising the native reliability of the PHY. It wouldn't be perceived directly by the link layer.
Sorry, I didn't get it. You mean that there are 3 levels of error correction in CXL, or 2 levels
No,
of
I'm
error?
not making any comment on CXL. I'm simply saying that we want to reuse the logical flit structure in CXL.
Okay.
And in that flit, that there is room for an error detecting byte, I believe, or some structure. A portion of the flit is reserved for a code.
Okay.
So Bobby, I guess the one thing that's sort of maybe implied here is that, well, I mean, I guess it doesn't have to be that way, but it is sort of implied that none in terms of sort of error correction in the link layer explicitly seems to be sort of not mentioned here, and I don't see Greg on in the moment, or maybe I just don't see him. I suspect that there are folks that would like to have none as an option for sort of even error detection, just because there might be application scenarios where that makes a lot of sense. Now, having said that, that's sort of that was kind of the original sort of discussion of, well, hey, like, if there are folks that really want none, we might want to enable them to sort of actually achieve that. But if we are all sort of explicitly saying that, okay, yeah, there's always going to have to be some sort of detection / retry or correction, then obviously that sways the argument in a different direction.
Right. So wait, those none is one of the 3 options, right? None, weak detection, and strong correction.
It's not in terms of coding, at least, and maybe I just misinterpreted your bullet item, right? Like bullet item number 3, which seemed to be sort of referring to error detection.
Oh, this was a discussion.
Yeah.
Okay, hang on. So maybe the right way to. This was the discussion. This was the sort of next steps. My bad.
No, that's fine. And so again, so just to clarify, is the implication then that like none is an option that people want to support for the link layer?
That's the working theory right now, that if you just take whatever the PHY layer gives you.
Okay, got it. So, and I guess maybe the next question then is, are there people that are interested in none, but also relatively high, sort of rates or throughput or whatever that would sort of drive the lower bit error rate?
Not to. not that we don't have it. We had to sort of ratify this maybe at one of our Friday meetings, but not that I know of.
Okay, because I mean, I suspect there are such cases, and by the way, I'm not trying to push for sort of one solution or the other. It's just I do suspect that there are such cases only because at the end of the day, people if people really are shooting for sort of a very low latency thing, which is sort of just an extension of an on-chip bus in some senses. Um, I can imagine cases where you really don't want to have to error correct the sort of the on-chip bus that you're extending, even sort of in the simplest example. But again, that's really going to depend on the application and the usage and everything like that. So in other words, I think it's all going to come down to, we can make a choice that would sort of say, hey, if you really care about reliability, you must do something, or we can sort of try and shoot for something that would sort of enable you to get to the none solution if you wanted to, even though the spec doesn't mandate that. And that's kind of why we were sort of threading things the way we were in terms of set the spec, for example, at 1e minus 18, which should enable people to hit 1e minus 20, for example, if that's what you really needed, but would not absolutely require you to sort of to hit the best possible thing if indeed there is error correction there.
Right. So I think what was I going to say? So the thing in my mind, there's always a distinction between what you mandate and what somebody could do, right? So
Yep.
you're just sort of saying leave open the option for none, and if somebody comes along and says, you know what, I'm going to provide none with a really really good bit error rate, that's perfectly acceptable.
Exactly. Now the sort of, I think the only quote unquote point of potential debate or really the point of trade-off would be, in order to enable none, that may mean that we need to set the requirement somewhat more stringently than you would have otherwise, if indeed we want to retain interoperability.
Yeah, I want to push back on the 1e minus 18 direction. I suspect. I mean, you have simulations which show that ought to be doable. With the
Wait, should we save that for item number 3, and I'll knock off this, like, there are
yes,
these ECC options, and then I'll walk you through the changes I made to the front end. Then we can sort of
Sorry,
get to the
Bobby, I
topic we know and love.
No,
about
sorry,
the
I probably precocked the discussion, so my apologies.
No worries at all.
Bobby, is there any basically motivation from the adapter team why they're gonna actually use Flit and retry rather than having it?
I think Flit seems to be okay. Flit is like become the accepted structure for dealing with transactions. It's just the way now. This is the way.
Yeah, but I just want to because we are not participating on those meetings. I just want to understand what is the motivation to retry, not error correct.
No, you're going to do error correction. The key question is, do you also so the two options are there. Essentially, you do think of these as two different axes. I've got none with I've got nothing and nothing, or I've got weak detection coupled with retry, or I've got strong detection coupled with retry.
And you gonna basically adopt all these options, or you gonna pick one of these as a standard?
Well, so remember, one of the key decisions was that you wouldn't necessarily mandate any additional ECC in the file layer to reduce latency. That all ECC would be concentrated in the lower link layer. So if you're dealing with a SerDes 5, which has a bad bit error rate, then you may have weak detection may not be sufficient to get you to where you want, that you may need strong
Yeah,
correction.
I think there is one fundamental point here that maybe we missed it in our discussion. I think the main reason that CXL guy are switching to this format is because they are targeting PCI Gen 6, which is PAM4, and PAM4 natively you can get E-5, the best E-8. That's why they need to bring that up with the very, very heavy FEC and more latency. They can afford that latency. Then they break it in two with the light FIC, which is a low latency, plus the retry. But for
Okay.
us, we are not PAM4. We can easily get to the e to the power of minus 15 or minus 14, 15,
Okay.
minus 18 without any FIC.
Right.
I don't see the point of basically following CXL at this point where we are not PAM4. We are at NRZ and we
Right.
are at
But
much better that error rate.
a flit is
I'm
simply a
getting
logical
something
way. A flit is simply a logical way of organizing your data, right? That's completely orthogonal to the
Yeah,
bit error rate.
but the flit is 4 by 16 bytes of data with 2 bytes of CRC. So it's basically already using some of the bandwidth for encoding error correction.
Or you can turn it
Right.
off and just do detection, right? You can. You're saying where
But then it's not a CXL flit anymore, right? Isn't the CRC built into the definition of it?
Okay, that's a good question. I don't know enough. I think that so it depends on how sort of religious we want to be about obeying the CXL flit. I think it's more like let's just use that flit size and the general structure rather than the exact thing as is my understanding. But it's a good question. I don't have a good answer to that.
That flit size
Right.
is
It
4
would
by
be
16 bits or bytes?
It's one
4
cache
by
line.
16 bytes, 4 by 16 bytes with a 2 byte CRC
Yeah,
over that group.
it's one cache line basically.
Yeah. So I think that, it'll be important to figure that out, right? Because that's uh, being in groups of 16 is a nice alignment. But if we're kind of embedding the CRC in the data, and then somebody chooses to implement a FEC bit in addition to that, you're losing a lot of overhead to error correction.
Yeah, but then we can turn it off, right? Then we can go for the none.
Or maybe use the FEC bit for this to transport the CRC data.
If you want to use a FEC bit to transport the CRC data, then we'll have to have a convention to do that. That'll have to be part of the Bow convention to do that rather than the link layers convention.
I
That
think
would be a
maybe I
link layer.
would. I think maybe I would rephrase what I think some of the. I don't know if concern is the right answer. I think the issue that's potentially being raised is just that if we have an FEC bit that's specifically defined, at the PHY level, but it's optional, when people are building the link layers behind it as they're sort of, and if the link layer is the one that's going to be actually using the FEC bit, then we're sort of, doing this thing that's going to be coupled all the way through in terms of the decisions that people make. And it may just become sort of awkward to sort of, handle all the different cases that people care about because of that. In other words, you could just take the position that, hey, like just do everything in band and don't have an explicit FEC bit in the PHY layer, and then the decision entirely sort of lands on the link layer. And if the link layer wants to have, the extra overhead of error detection, error correction, it can. If it doesn't, it doesn't. And that's not to say you can't do it with the other FEC bit too. It's just that, sort of there's sort of like two compounded decisions that are being, the number of cases that one would need to think about is being increased just because of there's, this sort of dual, there's two places that it's being potentially defined and used.
Wait, if I understand correctly, let you separate this out into three things. One is sort of the container structure. The second is some portion of the container always being used for an ECC or error detecting code, which is, I believe Mark's concern about link efficiency. That, you've got a reasonably reliable link and you're burning chunks of it for a code. The third is the mapping of the error detecting code onto the bow. Or do you want it to be transparent, right? Those are three. Is that fair to break it down into three distinct things?
I think so. Mark, does that make sense to you?
Yeah, I think that summarizes the three issues. Yeah.
So if you want to fully decouple the bow, I believe we have two options. One is to just use the FEC orthogonal to any coding in the link layer to just increase the reliability presented
Mm-hmm.
by the bow file to the link layer. Or we define an adapter which kind of says, hey, we're going to take any error detecting code in the link layer and map it to the FEC bit in this mechanism. Those are our two options as I see them. But that's not a link layer issue.
Yes and no. So you could define it that things that way, but I think what you're describing has now sort of made it so that the PHY sort of has to take on more responsibility than it did before. Right, because I think in both cases, what you're basically saying is that the PHY would actually perform the FEC and then just present something that has been corrected to the outside world, or that it's effectively sort of acting as the sort of the gearbox is not the right term, but the quote unquote the gearbox.
Right. But the question is, what's our vision for the effect bit, right? Do we see the effect bit as something that gets pushed all the way through the link layer and visible to the link layer, or invisible to the link layer?
Yeah, so my understanding from
Or
prior discussions, which may or may not be true, was that the intention was that the effect bit was just be forwarded along, and the PHY itself would not be doing anything with it. Obviously, that's a choice. That was
Okay.
That is the plan now. Yeah, that the FEC and aux bits are just presented to the link layer, and the link layer implements the FEC.
Or it could either be the link layer
Yeah.
or the link layer adapter, right? I mean, that's really the debate where we're presenting 17 bits, we're presenting a FEC bit, and it's up to the adapter to map the extra error detecting code onto that 17th bit. Am I missing something, or?
Well, you can't map an arbitrary FEC code into the 17th bit. If it's going to be kept in the FEC bit, then the FEC code has to be designed that way. Our team ended up choosing to mix the bit, use the bandwidth of the 17th bit, but mix the bits in with the data bits. So what's presented from the link layer to the PHY layer is 17 bits, which does include the FEC overhead.
Right. So
we could have separated out, but it would have been a requirement on the way the link layer did the FEC. And we ended up deciding it wasn't important to confine it.
Okay, so the flit structure. Okay, so let me do this since Shab, I can come back to your notes, right, in the link layer meeting. So the key questions are bandwidth consumption, and then right now the flit structure has 2 bytes devoted to coding. I mean, you can just pretty much say to transport those 2 bytes on the bow FEC bit. To me, that would be a bow problem, not a link layer problem, the way I understand it. We just are defined where those 2 bytes would show up on a flit.
So that's 2 bytes compared to 64 in the data content.
Yeah.
Yep.
And that fits within the FEC bit bandwidth.
Yeah.
Yeah, you would use half of the FEC bit bandwidth that's available.
Uh-huh.
I guess the way I'm envisioning this is you kind of have you have a few different link layer options, right? One you could just implement a simple link layer that utilized the FEC bit just to get error correction, didn't do much else, and just kind of presented a bus on each side, right? Which is I think Elad had mentioned, what if we want to move a bus from one chip to the other? That would be an easy way to do it. You could the second, I think you could choose to ignore error correction altogether. If you've got a good enough bit error rate, or you don't care about the data, that's a viable option as well. And I think the third option is a link layer that's more maybe this is where the link layer team is. They want a link layer that looks more like PCIe, so encoding the data in flits, and just having that overhead isn't the end of the world. And maybe that either just gets embedded into the data when you're not using the optional bit, or gets embedded into the data and the optional effect bit if you implement that on the PHY.
Yeah, and if you use the FEC bit for that, then you avoid having to do gear shifting.
Yeah, right. Which might be really nice.
Yeah.
Okay, so what do I take back? So, so can somebody summarize it as like what is the exact interaction, right? For each of these. So my question is the mapping from each of these to the bow our problem or the link layer group's problem? I keep feeling it's it's the bow team's problem.
I don't know. I think we convinced ourselves that the link layer could map whatever it wanted to the PHY as it's defined.
Yeah, and I think we want to keep it that way. Yeah, because I think. Go ahead, Bobby.
I'm sorry, I was going to say, no, it's got to be the adapter. The link layer itself, the protocol is going to be orthogonal to.
No, sorry, adapter. I automatically call anything that's not the PHY the link layer. My bad.
Okay, thanks. All right, then we're in violent agreement. Okay, it's the adapter, which so right now is the bow group's adapter problem, not the link layer's problem, but I guess it's at the intersection of the two.
Are we in charge of the adapter?
Huh?
Are we in charge of the adapter? Who's in charge of the adapter?
Right now, yes. Because somebody,
I guess the one guidance I might feed back to the link layer team is I understand the relevance of the CXL flit in systems today, but it might be valuable for them to consider other simpler implementations as well.
Other simpler than what?
So again, kind of rewinding to Elad's comment, like if you just want to have a bus on one side turn into a bus on the other side, running it through a CXL like protocol might be overkill.
Okay.
Yeah.
But I can see the appeal because the transactions on the bus are going to be cache line based anyway, and you're going to have a protocol on the bus whether you like it or not.
Yeah, but not everything's
super heavyweight.
Yeah, not everything's cache line based, right? You could have a sensor or something that wants to just barf out data to your chip, and
yeah,
building the overhead into that isn't very useful.
Right, but there are these things called data only flits as options. That you could just say my flit is nothing but data, and you look to the flit before and the flit or the flit after to sort of see what the control for the flit is. Okay, I take your point is noted. I will hopefully Shahab has notes. I will make sure I look at them before the next link layer meeting.
Okay, thanks, Poppy.
When we need him.
I got to remember not to say things like barfing out data while I'm being recorded.
Well, just FYI, I think we made a conscious decision to deliberately include the adapter. I was under the thing that the adapter was not our problem until 2 meetings ago. And we said, no, we want to specify the order in which data is serialized, et cetera, the serializer, deserializer.
I think on top of that, also, we really need to know if they are doing any error correction on that layer or not, because that's actually affect our decision on mandatory bit error, better bit error rate for the PHY.
Right, so these are the three options now, right?
But I guess, yeah, right. And again, to be clear, I would state that in a slightly different way of, I don't think we necessarily need to know if the adapter is doing error correction. but we need to know, like, we need to make a decision about, are we basically going to, yeah, I think it really just comes down to, do you want interoperability and supporting, sort of the option of having no error correction, or do you basically want folks that want no error correction to sort of, most likely not be interoperable because one side, because the other side might just be too poor for them to hit that constraint.
Are we on to the FEC stuff?
No,
Yeah,
let
good
me,
question.
we're almost out of time. I need 10 minutes to at least show you my changes, and then I promise I'll be done by no later than 9:45, 9:48. Are we done with this?
That'll give us 7 whole minutes before we have to wrap up.
Yeah. So,
Right.
but I
And
do want to show you what the changes I
sorry, but
made.
I just want to one more time to basically catch up the notes. Then basically the adapter group, they're gonna go with this 3 option, that they may not have any error correction, may have a weak detection or a strong correction. That's how they're gonna play the
This is what we're starting with, and this is the link layer group, not the adapter group. Right now, the adapter is our problem, not theirs.
okay.
But these are the 3 options that will likely be supported, that will at least will be investigated for the link layer. No additional error detection or correction, just weak error detection and strong correction. And there is an open on whether retry is optional or just not specified at all.
Okay, then basically didn't solve our problem. Okay.
And I think the feedback from Mark is there are 3 things, if I understand correctly, from Mark and Elad. One is, do you really want to burden every flit with the overhead for error detection? The second one is, what happens if you want bulk data transfer? And the third one is, what if you just want to implement a wire model? What is the exact combination of features that makes it possible? Those are the 3 questions as I understand them.
Okay, thanks.
Okay, so I'm not. So one thing I don't know whether everybody's aware, but you can, when you fork out, I just want to make sure, because I know everybody's going to be diligently working on this offline, but you can, when you go to a repo, you can see the forks, and you can go look at someone's fork. Their fork is also public, basically. So you can go to the fork and see what changes I'm making from wherever you are. So I can go to Ken Polton's fork and look at the changes he has in flight, as it were. Right. I don't know whether all of you are aware of this, just in case. Does this make any sense? So there's a long-winded way of me saying you can look at the changes somebody's made without in their branch, without having to merge it with the main branch. So the changes I've made, I have tried to. There are 3 things. One is I haven't touched the objectives much. I think it's a couple of language changes. Left this alone. I think we need a compliance summary table. Somebody has to volunteer to do that, because I'm reasonably sure I'm the wrong person for that.
I think I created one version, but we dropped it. If you remember, we waited to finish the whole spec and then update that.
I'm with you. Then I think I rearranged this a bit. So I kept the bow slice, and then I said bow wires, and then I have bow modes. Then the bow mode here. This is a rearrangement. Then this is my new diagram for the PHY link layer interface. So I think the changes you wanted the last time, if I have this here, PHY slice logic interface, remove the words not specified. Elad's text gets inserted. I'm not sure what that was, but oh yeah,
That's
okay.
the serialization order.
Yeah, and I have to go find that. I didn't do that yet. Okay, add some text.
I think I sent it to Ken, but I sent it to you too, but happy to resend. Just let me know.
Yes, please, would you?
Yep.
Add PHY reset and ready. I think I've done all these except this. And a pipe got moved. So then I created a section at the end which I haven't touched, which is just a cut and paste right now. So this is the simplified introduction. Then signal definitions. Ken had a question about there's a lot of redundant text. I tossed all of that. We've got data signals. We've got the DBI, got the slice logic interface, data signals, control signals. Phi ready, phi reset, ready on TX, ready on RX. Link initialization. And then we have this lonesome section on bow modes, which is much simpler now. And the question I have for this group is, should I just move this whole thing? This section is literally just this much. We can leave it like so, because the overview becomes very dense if you move it like to here. But we have two options. We can leave it like so, or just merge it with the overview, but which means the overview becomes more complex. So we can leave section 4 or replace table 2 with the more complex table there, and just have one table with modes. That's
I
one
think
question.
we agreed on a philosophy of keeping that introduction really introductory.
Yeah.
So I think that would, if we want to follow that rule we imposed on ourselves, we should probably leave the more complicated table later on.
Sold. Okay. So then
Can you go back to that more complicated table for a moment?
Huh?
I was just asking, can you go back to the more complicated table for a moment?
Sure.
Okay, so okay, yeah, I mean, I think arguably there's not really a whole lot. Yeah, I definitely would not move this table up. Arguably, I'm not even sure this table is necessarily right. This is all sort of representative, right? This isn't saying that any of these things are requirements. It's just other than what bow 32 means from a data rate and forwarded clock perspective, everything else is kind of up to the user, right?
Right.
Yes. Yeah. And the second sentence under bow modes says recommended.
Yep.
Breaches are seen in table 6.
Yeah. Okay. Makes sense.
So
Actually, we probably ought to put that in the recommended in the title for table 6.
Yep. No, it makes
Yeah,
sense.
I agree.
okay, I can do that right now. So then so then this week we're going to leave this. So then the questions I had, this one's no. So there's a whole bunch of shalls which I think were left over from Suresh's language. So right now, so the question I have is, in the way the bow interface is defined, on the TX side, we're saying the phi will assert TX ready. Let me give you an example as a question I have. Will assert TX ready when its clock is stable. Right now it says the phi shall assert TX ready when its clock is stable. Should I leave that shall as a shall, or should I change it to a must? I'm asking.
Must is defined as the same as shall.
Okay. All right. So then that answers that. So should we replace all shalls with musts?
It makes it easier to search, but other than that, we allowed the use of either term.
Okay. Then the last one I have is, right now in the link layer, I didn't have a training pattern. Is this an open item we are going to come to later? Do I mention it? What do I do?
As far as I recall, we said that we would leave that up to the link layer / adapter.
Okay. Even the per slice training pattern, because we needed a training pattern for clock alignment, right?
Right. No, but again, well, some phis may need training patterns, others may or may not. So the problem is that if you define them, then you're going to do something wrong for somebody. So I think that's why we concluded that we would just leave it as a decision for the link layer. Link layer / adapter, to be careful.
We're going to need to to be a little more careful about what training pattern looks like in order for the phi to properly align clock versus data.
Well, but again, that's not all FIs will have training patterns required at all, right? Some will, some won't, and like you see what I'm getting
But
at.
if we're going to be interoperable, we ought to between different links and FIs, then we ought to specify enough that any link is providing a sufficient training pattern for any FI.
So how should I say this? I do understand what you're saying, and you know, maybe there's a relatively simple set we can come up with. I think the issue we're going to run into is that you know, depending upon what algorithm you're using and what channel you're on and things like that, you know, some patterns are going to be you know, fairly specific to kind of the particular scenario. And so I'm a little bit hesitant in sort of, you know, saying that, okay, yeah, like, you know, all FIs will do this pattern, right? Like, so I think if it's, hey, it's expected that the link layer will support at least, you know, the following patterns, then I think that would work. But if we sort of say everybody must do pattern X, then that's where I'd be a little bit more sort of worried about just making the wrong decision for somebody. Does that make sense?
My comment is, I think it's most of the interfaces, they have a what you call a recommended pattern, and beyond that, user defined is it, right? Yeah. So as you said, it's probably it depends on how the FI has been designed and how their algorithms work. But without the recommended pattern and without defining some way of interfacing, I think spec is not complete.
I don't know. Recommended, I'm perfectly right. That's maybe I didn't communicate very clearly. I'm perfectly fine with saying, you know, it's recommended that you support at least the following patterns, right? That's perfectly fine.
Yeah, and I think that's okay. I think that we at least need to recommend patterns.
Okay, we need to recommend. So in my mind, I've always assumed that the per slice pattern is something the Bo spec will do. The cross slice pattern is something that the link layer will specify.
Sorry,
but each
the what? First slice?
Because our spec centers around the notion of a slice. So I've always assumed that, you know, whatever it takes for a single slice to, you know, for the clock to align, that
Okay,
will be listed in this document.
Yeah, right. Yeah.
Okay, so I need somebody to please send me a pattern or something, or volunteer to write this, and then those are my changes. The only one other change which I made, which you can look at, I put in an explicit statement saying this document is about the specifies a single slice. How multiple slices interact and data aggregation across slices is outside the scope of the document. Does that make sense?
Yep.
Are you saying that it's in there or it needs to be added?
I added that. I just don't remember where.
Good. Okay. Okay.
Okay, then I'm done in 10 minutes as promised.
Alrighty.
Okay, I think finally, Ken, it's time for continuing the discussion for changing bit error rate from -15 to -18. Do you want to continue the discussion, or we just want to have a straw vote on it, or what's the feeling?
I wanted to bring something new that came up last week,
Okay.
which was I've been a little uncomfortable with I've been happy to have the calculation of that Elad brought of showing the how he gets to 1e minus 18. I've been a little uncomfortable with saying here's an example of 1e minus 18, and therefore we're going to set a spec that everybody has to do that. And that was made a lot more concrete with a discussion with folks in the test chip group last week, where someone is trying to do a design that uses one layer per slice in the laminate and does not have intervening ground layers. Now that's certainly going to have a lot more crosstalk than the intervening ground layer arrangements. and is likely to impact his bit error rate. And in the spirit of allowing people to make things which are less expensive, and I think apparently layers of laminate is something that I've heard some pushback on, that's adds expense rather directly, that I think we don't want to go to what is the bit error rate that we can get with a really clean channel. And so that makes me think that I'm hoping that he can still get to 1 E minus 15.
So Ken, do you have
yeah.
do you happen to have sort of the data on what the crosstalk levels actually were?
No, he hasn't gotten to the point of being able to simulate that yet.
Okay, because the reason I ask is, obviously these are all sort of budgeting exercises, and with a number we can sort of just go back and check whether all the rest of the numbers still seem like they make sense or not. Yeah. Because at least preliminarily from the channel models that I believe were developed under the tester group, it doesn't look like crosstalk is all that big of a concern. Now, granted, they may have the extra intervening ground layers, and I agree that likely increases things, although might not be terrible. Just again, I think getting sort of some quantitative numbers would be really useful to just so we can know, like, okay, yeah, like it looks like crosstalk is really terrible and this makes a difference, then great, I'm all for it. But it might be that it's not that big of a deal, and then that may or may not sort of change the discussion.
Well, I still think that setting a bit error rate based on fairly high signal integrity arrangements is unnecessary.
Well, and again, just to be clear, I think the trade-off is I think it really does come down to interoperability versus yeah. I think it's just sort of an interoperability question, right? Of do we want people that potentially want to be able to operate without any forward error, without any kind of error correction, retry, etc., to be able to interoperate with others that sort of may or may not. Well, but yeah, and if we do, then that pushes you to sort of have a more stringent barrier rate consideration. And if you don't, then that still allows you to get to the error-free thing. It just means that most likely you won't be interoperable because one side might be poor enough that there's just sort of no way to put the two sides together. And I'm not intending to cast value on one versus the other. I was just trying to clarify what I think the trade-off is.
Yeah.
So
Yeah, and I think I want to.
go ahead, Ken.
Sorry, go ahead, Ben.
Oh, no. So my thinking is slightly other one. Without a compliancy measurements, how do we implement 10 to the power of 18 or 10 to the power of 20? That's one thing. And the second thing is an interoperability point of view. You're looking at only one extreme case, is that right? For defining the 1018, as other folks mentioned, like we have different channels. I think a spec point of view, what are the considerations when coming out with the 1018, and how do we do the compliancy test?
And just to be clear, I guess compliance is going to be true regardless of whether you're at 1 E minus 15 or 1 E minus 18, right? Like, obviously it's harder to measure things at 1 E minus 18, but that issue exists.
Yeah, that issue exists. I think its economies also comes into the picture, is it right? If you have a tester running for a huge number of days, you can get that, but that is not economically viable, is it right? Like from most of the specs, they stop at 1015. That's I believe, but I'm not 100% sure.
I guess I feel the need to point out that most memory interfaces in the world operate below this level, right? And they don't do the the infinite tester time on those either.
Yep.
They operate below the level, but do they spec below the level?
Yeah, I have the impression the specs are more like 10 to the minus 12, 10 to the minus 15.
On the memory interfaces?
On SerDes interfaces.
No, on SerDes, sure. I was only pointing out that, like, it seems like and this is fine, right? Like, I think a lot of us came from that same community. In the SerDes world, that is indeed the typical place that people are at. I was only pointing out that there are, approaches that people have taken to be operating at these much lower error rates and, have gotten past the how do you test it in sufficient time and so on and so forth. So I was only trying to point out that, I don't think there's an intrinsic reason that one can't, sort of make those types of things work. And again, I'm really not trying to cast the value judgment on what the right answer is. I just wanted to make sure that we're sort of making the decision on what I believe is the key axis, which is really just, how important is interoperability to sort of, the cases where people do want to operate without any error correction.
Can I make a couple comments?
Sorry, I think you made one comment about memory. If my memory actually recalls correctly, DDR4 is also 1 e to the power of minus 15. With
Right, but if you
before.
look at all the interfaces before that, right, they're all effectively error-free for all intents and purposes.
But at the DDR, am I right or not?
I'll put a number
DDR4.
on it. That's not. What does error-free mean? That's you got to put a number on it.
It's the 1 e minus 20
anything.
I think
Okay.
DDR4 before FIC is minus 15, after FIC is minus 21.
Right, and as I was saying, right, if you look at sort of the, so an LP case, right, for LP5 is the first one that sort of introduced the link, sort of error correction, or the line one, I forget what they called it, but everything before, obviously there's a huge amount of data you're shuffling back and forth, and effectively it's assumed that the link part of it is error-free. Error-free obviously means to within some, failure in time metric. But that, as I said, that was really intended to be more of a side note than anything else. It's just, it was intended to sort of clarify what I believe the sort of the main trade-off is.
And I think we're probably going to have to shelf this for next week's discussion. But I think in the meantime, I'd like folks to maybe in your offline study time think about how we might want to come up with a kind of a middle ground, which is similar to what we've done in previous areas of the spec where we've had recommended and required kind of step functions. I know that I personally struggle with the 1 e to the minus 18 from a flexibility point of view as well. So I definitely am very interested in working together to see if we can find something that kind of points folks to a direction of achieving better bit error rates for interoperability, but doesn't necessarily force major design choices to achieve it. At that note, Bobby, you had mentioned you wanted to kind of line up our agenda for next week. I guess I'd propose let's try to work through the bit error rate discussion a little bit more. I think we never got to the bump ordering from Ken either.
Yeah. So
I think we'll want to add those for sure.
At least on the bit error rate, I feel like we're at a point where sort of we're at the place where we know all the data. It's just a decision for us. It's the decision is do you tighten the spec or not? Really, it boils down to that, and whether there's enough evidence to merit tightening the spec. I think that's my understanding of this, and given that I'm not an expert, but it's not for lack of data anymore. It's more like we just had to jump one way or the other.
Can I volunteer maybe to try to write some words that at least I would be supportive of and share those with the team next week?
Yeah, sounds great.
Okay.
I think we are almost run at the time, and other people from the other meeting is joining us. If you don't mind, I can list what we're gonna do for next week and jump to the next meeting. I think Mark, next week, I think we're gonna expect that you do some presentation on minus 15 to minus 18, and then we can vote on it. And then also, Mark, you want to talk about the CLA solution, at least put it on the heads of the people to think about it. And then we can continue on the bow pattern suggestion from Ken, and also there are a list of the opens that Elad also shared that we can go over those if we find time. Anything else that we should have for the next meeting?
Sounds like it. Thank you, everybody. It's been a great discussion today.
Thank you.
Thank you, everyone. I think Bobby
Thanks.
meets
Hey, I'm just
on.
going to keep the bridge on.
Yeah.
Let's see. Can somebody volunteer to take notes for this bow for the bow test chip meeting? Anybody we're able to? I can give you permission. Wait. All right, I'm going to name names then. Let's see.
I'm tired from the previous meeting.
You're
Sorry.
tired. Satya or JP, can I volunteer one of you gentlemen to take notes?
Bobby, you're asking me for the notes, right?
Yeah.
Yeah, I can take the notes here.
Awesome. Hang on then. I'm just going to give you permission. Okay, Satya, you just signed on for next week.
Oh, I'm sorry, I'm on mute. Yes, I'll take the notes next
Thank
week.
you.
Bobby, can you all send me the link for that notes?
I'm doing that right now. I'm sending it to you and Satya. Okay. Okay, so we have two items as far today in my mind. One is I think I'm beginning to get a clear sense of the way we should approach the test chip versus the spec discussion. And the second one I think is the bump map discussion that Ken has been sort of moving along on the side with everyone. My vote is we do the bump map first, unless there are any objections. Or should we wait for Nam Hoon or if Javi's here? Okay, that's good. Do we wait to build up more of a quorum for the bump map, or do we just get going? I'm asking. Ken, you're still here, right? Okay.
Yep.
Anybody bump map first, or the sort of more philosophical discussion first?
Bobby, why don't we start with the bump map?
Analyze the bump map. I think we are over it for a couple of weeks. And it may actually affect the spec in terms of the wire order. I think it's good to make a conclusion on that.
Okay, then Ken, all yours.
All right. How do I share? Is this screen? The screen button?
Yes, the screen button.
Ask the organizer to make you presenter.
All right, fine.
Isn't there a way to configure this that anybody can present?
No idea, man. Probably. All right. You should try now, please.
Okay. I only want to. Okay. There we go.
So, Bobby, before we get started, the access you've given me, not the right email address.
Oh, okay. Oh,
So
I need to
can you get me my email address.
Yeah. 1 second. I think I know which one it is. I forgot. Wait. Oh, I got it, right? The EPDC thing.
Yes, exactly.
Okay.
Yeah, thank you.
Got it. Ken left. Okay. All right. He's got sharing problems. All right. He's got to do a reboot. Hey, so while we have it, here's my suggestion on a bunch of things. So the bump map discussion, anything which is reference, right? Like bump map and a couple of other things, I'm thinking that we just create a separate implementation spec for the bow test chip and not try to alter the base bow spec unless we really need to. So something like bump map, I'm beginning to think maybe we're better off just creating a second spec for the bow test chip. That's where my head's at, and which will sort of simplify our discussions, because moving the bow spec is like a heavier affair.
I think there's sort of two. I think there's 2 points. So I like the Solomon approach or whatever, but I think there's 2 things that maybe are worth pointing out.
You hear me?
Yes, we can.
Go ahead, Elad, please.
Yeah. No
All right.
problem.
Sorry,
Oh yeah, we were just
Okay.
waiting for you. We got started on this topic of how to separate out the boat
You'll
test
have to
chip
make me
discussion
presenter again.
from. I'll make you presenter.
Yeah, Bobby, we can loop back. We'll why don't we go into Ken's thing and then we can loop back.
Okay.
Sorry, I fat fingered something and somehow exited the meeting.
No problem.
All right, now can people see my my PowerPoint? Can you guys see my slide?
Yes. Yes, we can.
Okay. All right. So this is the figure that is in the current spec. I've been referencing the March 2021 version, but I think it's still in the current version that we have. And it was pointed out that this was used as the example for a minimal link, and it was pointed out that chiplet A cannot be the same as chiplet B because you've got the reverse order of which is there an RX or TX slice closest to the edge in position A. So clearly this ought to be the correct example for the minimum bidirectional link, where chiplet A could be the same as chiplet B, or at least the link looks the same on both chiplets. So I propose to go ahead and make that change in the spec relatively soon. Is there any question or discussion about that part of it?
One minor comment, it'd be the power supplies. Just have the RX have, I guess, more TX. I'm sorry, have the RX have more ground and the TX have more power, so that way it's balanced.
So power is explicitly not part of the spec, and there's a lot of waffle words around. You can do any power pattern you want, and I guess I'm not even convinced that having equal numbers of power and grounds is even the right choice. Is there a general belief that equal numbers of power and grounds is better than a few extra grounds?
Well, that's fine. If it's not called out specifically, then that should be fine. People can do what they want.
Yeah, there's explicit disclaimers that power patterns are a separate implementation choice. And maybe I can make that more explicit in the closer to the figure so it catches your eye more. Okay, so the next thing that's in the spec is when we go to a link that has multiple slices stacked and multiple stacks. The recommendation that we put in the spec was a checkerboard pattern, and this is like somewhere I got a bunch of. There are a bunch of different ways to that you can think of considering these, and these are all whatever we put in. Again, the phi spec is really talking about one slice. It's making requirements on one slice, and so whatever we put in is a recommendation for how links are arranged. Multi-slice links are arranged. It's not a requirement. We'd originally gone with checkerboard because rather than alternating TX RX stacks, because if you have an odd number of stacks, then checkerboard is more compatible from chip to chip. But with there are two things that were pointed out that may make alternating TX and RX stacks more attractive. One is that the minimal link wants to be side by side rather than a TX-RX stack. And the other is that it will certainly be, in many cases, attractive to make a TX-RX block that you can use as a building block. And if you're doing that, then TX-RX stacks, as shown here, is a more natural way to do things than checkerboard. And so those two things have convinced me, at least, that the recommended arrangement ought to be alternating stacks rather than checkerboard. Is there any discussion or question on that potential change?
That certainly makes sense to me. If I just wanted to, mostly for my own education, there's sort of a note here on the slide about that you can only do even number of stacks, and you need at least two for their alternating. I didn't quite follow why that would be the case. I think you can do odd, can't you?
Well, so if you're doing a symmetric link, then
I see.
Then you have to have a TX and an RX, and they have to be in different, and you need two stacks, even if the stacks are only 1D.
Is that right? So you can certainly do one stack, right?
Well, if you do one stack, you know, a TX over an RX.
Oh, I'm sorry. Maybe there's a terminology thing. When I said one stack, what I mean is, you know, stack depth equals 1, meaning just only one row on the edge in this orientation.
So, you know, this is a stack, just one set of slices.
Correct. In other words, what I was
one to end slices stacked up.
Right. So sorry. So what I was trying to say was that if you had only T0, and again, maybe this is just an interpretation thing. If I had only T0, R8, T4, R4, etc., that's allowed.
Yeah.
Okay. Yeah. No. So I think I'm probably just misinterpreting the statement, but I think it all makes sense.
Yeah. All right. So if there's not any.
Sorry, Ken.
Yeah.
Question. I don't know if anybody talked last week. I missed the meeting last week, and I think you were proposing the checkerboard pattern, correct? That one in the last.
Yep.
And we discussed the week before that loopback is an issue. With the checkerboard pattern, we can't have a loopback because these RX and TX slices need to be separate.
Why they need to be separate?
What level of loopback are you thinking of?
On-die loopback. I mean, the TX RX macro will be a one macro, and then side by side, and the loopback will be done within the die, the RDL or the other layers.
Yeah. Yeah. So if what you wanted to build was a side by side TX plus RX macro, then yeah, the checkerboard becomes inconvenient for that.
Right. Can you explain again why this is preferred in spite of this issue?
So please listen. The checkerboard has been the preferred, but what I'm proposing is to switch to the alternating being the preferred.
Oh, like what the top one?
Yeah, I'm proposing to make this the new preferred one that we put into the spec as a recommendation, not a requirement, and to remove the description of checkerboard.
Got it. Okay.
Yeah, that's in line with what we've been converging on. So
I'd like to
right.
to ask if there are any objections to making that change.
And the other thing is, if you're saying that it'll be a recommendation, right? But if somebody else implement the stack differently,
Yes.
Would it be an interoperability issue?
So it's certainly an interoperability issue that you think of someone implements the alternating stacks like we have up here, and someone else implements half and half or a unidirectional link.
Right.
Then they have limited how many can interoperate. But it's necessary to allow that kind of flexibility if we're going to also allow asymmetric and unidirectional links. So that's why this ordering is all in the recommendation area.
I think, Ken, I agree with JP. We have to decide one and go with it. The other one, like the routes are going to be different, right? If one is doing this, if another one is doing different, then we might need a bit skewing.
Right. So we might need a what?
If the distances are different, if you do like one chip is using one of the options, the other chip is using a different options, then the routes between them, the traces can be different, and then skewing might not be a good idea. There will be a skew. It's not going to be.
So I'm working with the assumption that rerouting things in the wire domain is essentially not possible, or so expensive that it's not possible, and that if you end up with something that's alternating stacks and you're talking to a link that is a different pattern, say it's the half and half, that all you can interoperate. Think of this one rotated 180 degrees on the opposite chip. All you could interoperate in would be these two middle stacks.
Exactly.
With these ones, and that's kind of limitation that you would have of interoperability.
I think what we should do, we should choose one and stick with that one.
Well, I agree, but I also think we can't require it. We can absolutely recommend it, but I think we can't require it because we also want to support asymmetric and unidirectional links.
The question here, like HBM, like those kind of things, they have a set pub map or not?
They do. Yep.
They do that. I think we should stick the same way.
That follows the JEDEC standard. It's kind of nice and clean, and it would be nice if this could be like that. But this is a little different from just DRAM.
At the end, we are transferring data, and we have to. If we don't lower the bit error, like a picojoule per bit, if we don't.
No, I agree in principle. Yeah, it would be nice.
I think
right, but symmetric links is not the only case. Asymmetric and unidirectional links are some of the use cases.
Right. I think that sort of the happy medium is to sort of have the recommended one, and certainly pick one as the recommended one, and sort of have the focus of discussion and examples that are worked out and etc. be that recommended one. But I do think that just sort of enforcing signal ordering on the exit is a clever way to allow people to do other things that we may not have thought about in advance. And if hopefully everyone is motivated to sort of interoperate, and if all the examples are sort of on one particular recommended thing, and everyone sort of finds that that's working well for them, then then the right thing will happen. But it just still allows flexibility to somebody to come up with something clever that we haven't come up with yet, that they may still figure out a way to make it work.
But Elad, for example, a company like big companies like us, Facebook or others, we want this to be chiplet to buy it, right? But if it is, we want to buy different chiplets from different companies maybe in the future. But this thing is going to be, if you cannot create an ecosystem here, like if someone, I understand,
I completely agree with you. I completely understand the motivation. What I was getting at was that, even in that example, and as Ken I think was pointing to, right, there are going to be cases where you have stuff that's asymmetric, right, where you have 10 transmitters and 3 receivers, or something odd, strange like that, right?
Or 100% transmitters. I mean, that's I'm actually implementing a link that way.
Yep.
I see what you're saying. If how many they put, how many they implement. I see.
I think my question is, even if we have a asymmetric arrangement, can we do something like, hey, you need to go in Y direction before coming to X direction? Or without that, I think it's going to be interesting, is it right? Like, look at first one and the third one or the fourth one, they're totally different. If somebody is following the first one, somebody is following the third one, how do they marry?
So if people are following different arrangements, then they will only be able to interconnect a few of their slices. And that allows for a minimal amount of interoperability between different arrangements. But yeah, if we're doing symmetric links, then clearly the alternating stacks is the preferred way to do it.
Yeah, and again, I think we're all in agreement that we should sort of pick one and sort of drive that as the recommended one. I think it's just, maybe, I believe Ken shares my hesitation, but my personal hesitation is just, if we say no, you must do X, then that's where I think there might be issues of again just sort of locking things out that a lot of people would actually want to do.
One other thing maybe help us, like maybe we should decide bigger, like if you do a 0.5 terabit transfer to identify how should it be. It should be one layer or two layer, a stack up or not. It can maybe help us here by bigger bricks too. Like we have a word what if someone has to implement, let's say 256 gig or 1 tera, we should guide them. We should put some guidelines there.
Other than guidelines for the depth, stack depth.
Yes. For example, like 1 terabit, two ways they can implement, right? They can go to only one layer and go all the wide, or like they can stack up 8-4. If you put the guidelines there, it can be more ecosystem friendly.
That's true, and the stack depth is primarily limited by the layers in the packaging. I mean, in laminate, it's directly related to the number of layers you have. In more advanced packaging, it's not clear to me what's going to limit the stack depth.
Yeah, so I think that how should I say this? I'm having recommendations is obviously perfectly fine. It's just that I think that there's always going to be a trade-off between sort of how much you specify and at how high of a level versus what are the cases that maybe we have not thought about yet that people will actually be doing. So I think you can put recommendations down. It's just that, for example, because of exactly what we have just said, right? There's going to be people that are going to be sort of heavily focused on laminates and may want a very small number of package layers. And there's going to be other people that are doing some other interpost technology where it's actually preferable to go the other way around. And I just think we'll very quickly hit sort of, the tyranny of enumeration of all these different cases. Which may just result that the recommendation is not particularly useful because of it. Unless we know of that there's like one or two cases that are really the most common ones, which if we do, great.
But Elad, for the different packages, if we come up with different technologies, people might know what they're expecting, right? Like if I'm going to use the both chips at the same package, if they line up, it's easy for me to build a system or co-packaged.
Yeah, no, I understand. Like I said, I'm not opposed to sort of giving recommendations, right? I don't think there's necessarily a harm in that. It's just that I guess the warning I wanted to give is that from having done this exercise a little bit myself, there's a combinatorial explosion that I think is likely to happen. And if you end up with a 100-page document of sort of all these different cases, it could indeed be very useful, but it might also just become sort of the answer it would have been anyways, which is, well, people are going to sort of figure out what they really are intending to do, and then sort of make it work.
So, but
I'm interested in people's look at people using laminate technology and how many layers they think is effective for their applications.
So So 4 slices deep is the upper limit of what's practical and organic.
Okay. And are people interested in using 4 slices deep and paying for that level of technology, of Packers technology?
I would assume so, although it comes down to the cost delta between that and an interposer.
Mhm.
And that economics is changing regularly.
Yeah.
Okay, my opinion, 2 cents opinion is if you do not have a recommendation, it's open and there's so many variables, people can do so many combinations. At the end, I think its interoperability is going to be problematic. My opinion, we have to have some rules and governing what is the bump pattern and the arrangement of the slices. Without that, I think we'll end up with unusable interface.
So could we split this into recommendations for symmetric, recommendations for asymmetric, single-sided, something like that, 2 types, and use that
Yeah, I mean,
strategy?
I think that's reasonable. But again, maybe just to clarify, I'm not at all opposed to recommendations. That the warning that I think I was attempting to give is that, you know, as Ken was saying, right, like there are going to be folks that are going to be all transmitter, or there's going to be folks that are all receiver, or there's going to be folks with, you know, 9 and 1 or whatever it is. And so I think that we're going to very quickly find ourselves, you know, sort of just trying to enumerate the world. And, you know, and again, if there are very common cases that we all know of, awesome, like we should certainly include those. But I personally, at least, you know, one of the things I really like about BOW is, you know, sort of if you specify the signal ordering, you specify, you know, essentially how things are expected to happen, you know, sort of as you go around the die, you know, that actually still leaves, you know, that gives you actually a pretty good idea for what you're supposed to be doing. And, you know, gives actually a pretty good chance to interoperate in the cases where that is going to be clearly a thing that you're going to do, right? Like you know, said another way, and I think there was another gentleman from the other meeting that sort of pointed this out. You know, this isn't going to be a USB cable, right? Like people are going to have to look at the data sheet of both sides. You're going to have to make sure you know what it is you're doing and what you're plugging into what. And given that that's the case, you know, that there's some amount of design work that's going to have to happen, sort of, you know, no matter what we do. And again, I'm not at all opposed to reducing that design work, right? That's great. It's just that I suspect that we'll be very quickly sort of finding ourselves in like, well, here's 20 different cases we came up with already. And if we want to, you know, sort of put them all down and document that, again, that's great. It's just I suspect even that list will not be anywhere close to exhaustive.
That's a kind of worms, is it right? If we have 100 of combinations, if we are not recommending a few of them, I think people go and do 100. And at the end of the day, I think we are trying to integrate many chips onto the package, and it's coming from different vendors and looking from, I think it's from different aspects. So I think it's at the end of the day, can we use all of them? Probably it's not. So if you recommend, for example, if you go with whatever you recommend is the 4th from the top, will it work for all the asymmetric and symmetric? So that is the probably we need to think about it, come out with a few combinations and recommend this one. Beyond that, I think the user issue.
Yeah, no, like I said, if we can reduce it to sort of a usable space of the things that you know we see as being most common / you know the best patterns, you know, I'm definitely all for it.
So for what it's worth, I was going through all the old notes on the checkerboard pattern. And one of its selling points was that it was more tolerant of alignment mismatches. Now I'm just going through the notes.
The checkerboard?
Yeah.
Yeah.
Can someone help me explain? Can someone help? Why is that?
That you could go ahead.
That if for some reason you had the link on the other side had to be misaligned versus the had to be misaligned by a slice pitch from the other side, that with a checkerboard you could still at least make some connections, whereas with the alternating TX-RX stacks you would make 0 connections. I'm, given that these things are millimeter wide, I'm not that concerned about chip placement constraints not allowing us to shift the chip, one chip versus another by a millimeter.
Gotcha. Okay, I see. So in other words, it was just that if your checkerboard, you can like throw away one link in each one or one slice in each one, but sort of connect the others.
Yeah.
Okay, I got it.
Yeah.
Okay, makes sense. Yeah, no, I tend to agree. If you're off by a millimeter, then we probably have other problems.
So,
All right, so
at the time we did this, I'm trying to dig through my notes. We were just getting the first word from the AIB guys, and the alignment constraints made lining up the chiplets in a package much harder was what we had picked up informally, and that sort of influenced our thinking. That then if you have this very tight constraint and orientation, so we were trying to sort of do something where you could have a lateral displacement and you could turn something 90 degrees and you would still get a reasonable wiring solution. That was looking through my notes, that was the motivation for the checkerboard pattern.
Yeah, but basically we end up with a sort of a 2 millimeter grid of possible placement versus the next chip versus 1 millimeter placement versus the next chip, and some compromises in how many things can connect with the checkerboard. So I think that's also a win actually for the alternating stacks.
Bobby, quick question. Are you recording this?
Yeah, as far as I know.
Okay, thanks. Just want to confirm.
I see a little recording light on. All right, so Poppy, do we have a enough of a quorum of the BOE-FI committee to agree that we can switch the recommendation?
No.
All right.
Well, I think the one thing I would go in, and maybe if we're going to do this, we have to write down why we switched and then what would it take to switch again, for sure. Because we spent a decent amount of time on going to the checkerboard the last time around. I'm not complaining. I'm saying if you're going to undo it, we should have a higher pain threshold.
All righty.
Hey, but I do want to point out one thing, right? I mean, we can leave the spec as is, and we can just choose a bump map for the test chip and the first family of chips to be implemented. The two decisions are not mutually incompatible.
Yeah, but we ought to have the right recommendation in the spec. We really don't want to have a checkerboard recommendation when we've already concluded that a different organization is the preferred one.
Maybe another option can be, for example, today we can choose something. Whoever wants to build their test chip, they can go ahead. And 3 months later, since the design is going to be the first, right? The bump map can be a little flexible to change. And 3 months later, for the test chip, we can say it's the final date. Do you think we can finalize the bump map in 3 months?
Well, I mean, certainly, yeah.
Okay, in that case, like today, if anybody wants to start, which one we are recommending for today's data? Like maybe we should vote that, and people can start doing their research according to that. And 3 months later, or August 15, we can say that for the test chip, this is the way to go. And maybe take 6 months. If anybody come up with a really good idea for the real product, we can change it.
Yeah, I don't think it's gonna take us nearly that long to come to agreement on that.
Okay, in that case, like maybe to make the decision, the initial decision, maybe do it in 2 weeks, and the final decision for the test chip in 2.5 months. Is that fair to everyone? Like according to that, we can raise money internally. That's what we need for the end users too, right? For the test chip, we have to have some. We have to give a signal to the start. That's what's necessary. Any objection
Yeah,
to
I think that's okay. I mean, I guess maybe I don't. Well, I guess I'm going to make an assumption, so I'm very happy to have somebody contradict it. I don't believe there's actually a lot of controversy on the alternating versus checkerboard at this point. My impression was that we'd largely converge there. So I think we can potentially just make that decision today. And then I think there are other confirmations of packaging that are probably more controversial. But this particular part, my impression at least was that there wasn't too much debate about.
Okay, but Bobby asked that I formalize the reasoning better before we formalize the decision.
Right. No, that makes perfect sense.
But two things, right? One is the bowl meeting is probably the best place to sort of make changes to the spec. And two is, we spent an agonizing amount of time on this checkerboard. I remember I'm going through the old emails while you're talking. I think from May through November of 2020, there's a whole bunch of Suresh did a whole thing. So if we're going to undo it, which again, I'm not pushing back on that, we should at least have a threshold for that. Okay, we're not going to undo this unless there's some specific reason to undo it. And
so Bobby, checkerboard sorry, go ahead.
No, this is Sid. I just had a quick question to follow up from Bobby, right? I mean, has any new data emerged from November 2020 that is causing us to look at alternative bump maps? Because I'm sure the team spent a lot of time over those 6 months looking at all the assumptions, right? So
yes,
bump maps or these stack groupings.
I think either, according to Sid. Like, I think the way I'm interpreting Sid's question is, what's the triggering condition to change our decision?
Right.
So in terms of the stacked organizations, it's basically well, there was an error in terms of what would be the right minimum link. Is it this side by side, or is it this stacked? And actually, that was an error in the way that we conceptualized it previously. And then there was just more input in terms of how people would like to implement this. That I think has certainly made. It's just more perspectives that I think has brought the insight to me.
I thought the trigger
information we couldn't have gotten back then. Just we didn't.
I thought the trigger for the change from checkerboard to alternate is really the loopback testing.
So yeah, to answer your question directly, there were two things. One, Namhoon found a problem with the bump maps, which caused Ken to revisit the basic bump maps for a slice. Two, but I think in some sense there was a push to also sort of change the aspect ratio for the bump map. I think we've come to the conclusion that the bump map, the basic bump map design we have is probably more scalable across all the bow operating points than a sort of squarer bump map. That's at least the conclusion I took away from the meeting a few weeks ago. Then the second one, the checkerboard, is triggered by, I think, this JP's point about a loop, some finding about, hey, loopback is going to be incredibly hard in checkerboard. Those are the two
got it.
deltas. Maybe a sort of a deep, trying to make it work triggered this. And I know we hadn't considered loopback in the original thing. That much I know.
So we had these two proposals, right? Proposal 1, proposal 2. I think we reviewed those over the last month or so. I think Bapi, I think one of them was more rectangular, one of them was more square, right? I thought the
Right.
one that was more square was proposal 2, if I'm not mistaken, which was more scalable in terms of speed, right? We could go, I mean, it was not restricted to half a terabit or less. It can go up to over a terabit, right?
No.
Is
Yeah,
my
go ahead, Bobby.
understanding right? Is my understanding right? I'm just trying to refresh my memory here.
Well, it depends on how you define scalable. Sorry, go ahead. Sorry,
No, that's fine. Go ahead, Bobby.
No, please go ahead, Eli.
Okay, yeah, no, I was gonna say, I think in terms of the data of, you know, there's the original one, which is more rectangular, which is sort of shown in KED slides, you know, up above here, and then the alternate one, which is more square, being quote unquote proposal 2. I think all of that is correct. The what's more scalable and what scalable means is where there's there's debate slash perhaps further discussion to be had. Yeah, there are some trade-offs between them. I think the one thing which I think everyone did agree on is the version that is more rectangular allows you to do a single link in a single layer package, whereas the square one does not. I don't believe there's disagreement on that one. And then whether or not the rectangular one is better for speed, performance, etc., versus whether the square one is better for speed, performance, etc., relative to the square. At least I personally held the opposite opinion of the one that you had stated. So that's where at least I would believe there's somewhat sort of further discussion to be had. But I think everything up to that point was correct.
So Ella, sorry, just to clarify, so your understanding is that the more rectangular one is better for speed scalability, not the square one?
I think there's a little bit of a pick your poison type of thing of there are perfectly consistent ways to do things where the square would be better, and there are perfectly consistent ways of doing things where the rectangular would be better. And so it just depends on how you're actually implementing it that sort of pushes you one way or the other.
When you talk about square versus rectangular, are you talking about the aspect ratio of the bump patterns?
Yeah, basically, and there was a couple different variants of it. One was sort of keeping the same bump pitch, but effectively just using two stacks to implement sort of a single slice. Stacks in the sense of going into the die edge direction.
Okay.
And then there was the other variant that I believe Gary had mentioned last week, which was sort of intentionally increasing the bump pitch. But then sort of getting like 50% of that back by having an additional row of bumps sort of fold in on the bottom, and then just sort of escaping on a single layer. So that's sort of the progression of different versions that I think we've discussed recently.
Yeah.
So I want to, okay, so we're down to 15 minutes, my God. All right, so we need to reach a conclusion, and I'd like to split the discussion into three. Number one is checkerboard versus stacked, and in my mind, everybody seems to sort of going back to stacked, and I think that's fine.
Okay, just clarify. Stacked, you mean alternating? Is that right?
Stacked alternating. Let's call it a mini board, right? Checkerboard is a mini board. And,
okay, sounds good.
And then the second one is the bump map. I think this whole notion of there were two goals for Bo. One is to scale across a wide range of performance points, sort of all the way from 64 gigabits to 2 to 6 gig per line, and across laminate substrates, etc. It feels like it's the per slice bump map that we had with one minor adjustment that Ken is, I don't know whether he's already shown it or not, seems to meet that better than anything else we've seen, because you can do sort of cheap small links with cheap substrates in a way that you can't with the more squared aspect ratio. That's at least the conclusion we walked away with either last week or 2 weeks ago. Finally, I feel like we should be open to the idea of making a Bo test chip which may have a separate performance optimized bump map if we're going for a high performance Bo test chip. At least I think it's an okay option.
So Bapi, the question then is really, what is the objective of the test chip, right? the objective of the test chip is to show some success for BOW quickly, then I agree. That's what we should do is pick something and allow that effort to proceed, right? So that there is at least, I think right now, there's folks out there who are looking at us and saying, okay, can somebody show some proof points here, right? And
Right.
if you want to demonstrate a proof point, we don't have to have the absolute final perfect bump map, right? In the test chip, we can be 90% there and show something that is successful. And then the effort to kind of super optimize it to every use case that we can think of can continue in parallel and keep going, right? And as the ecosystem evolves, that effort will continue, right?
Exactly. If we're trying to make a terabit per link test chip, and then we go off and optimize it for a terabit link, and maybe we come back and update the spec in version 2 or 1.1. But it feels like we're imposing a heavy tax by saying the reference bump map should be aligned to the Bow test chip, should be aligned everything else, and everything gets slowed down with this major alignment push.
Exactly.
That's where my head's at. I'm happy to. Any takers? Objections?
Sounds reasonable to me.
So, Bapi, I do propose to take this back to the PHI group and ask for a decision to make this change in the spec.
Okay. And wait, what about the change in the single bump map? Namhoon's here, right? Somewhere, right? He was here. Yeah. He's reviewed it as well? The one.
I don't remember whether Namhoon has seen it.
He's the one who found it, so he might as well like.
Yes.
Sorry, this is what's in the spec now, and based on you're pointing out that what's in the spec now is not rotatable. Right. That this would be the new thing that's in the spec.
Yeah. That's what I proposed. Yeah. Slide 23.
So I guess I'm proposing that we do for the test chip what's best for the test chip, and if it all works, then we push it into the Bow spec, or we decide to be like not follow the recommended bump map. But if the objective of the test chip is to achieve a terabit per second link, then that's what we do. Just because we don't use the reference bump map doesn't mean there's not a lot of value in it, as far as I can see. I don't know whether Halil, you or Ilad, or Satya, what you guys think, but I'm sort of coming to that conclusion that by trying to couple too tightly, we're going to slow everything down.
Yeah, I think it can proceed separately.
Should proceed. But you said that 1 terabit, like you want the whole interface or you want a portion of it?
No, I thought my understanding is we've all gravitated towards a test chip where it's going to be a Bow 256.
Mm-hmm.
And whether we can demonstrate a full terabit link or whether we're going to just demonstrate a couple of Bow fast slices, but we are on the way to demonstrating a proof point for a terabit link, is the way I understand it.
Exactly. I think that the test chip should be that, and after that we should like maybe couple later, right?
Right. And so if everybody decides that the reference bump map and the Bow spec is not good for a terabit per second, then we can change it, but we shouldn't sort of go back and then beat the Bow spec to death saying let's change the reference bump map there, because then we'll be going round and round for a while. I don't know, Javi, Anu, anybody else? I mean, I guess my proposal on the table is I think there's enough evidence that this bump map is good for Bow, as to meet all of those objectives. And if we want a different bump map for the test chip, let's go do a different bump map.
Yeah. That's explicitly
The only concern I have with a different
allowed
map
in the
for the
spec.
test.
Sorry, Javi?
Yeah. The only thing that's, as long as what's in the test chip still follows the same order, and hence the same spirit of what's in the spec, then that's fine. If it's something that's more dramatic, it's going to set a precedent. That might be, you know, as we publish more information on that with a different bump pattern, I think it'll be confusing, and you know, I just don't want to have any interoperability issues that come up in the future because of interpretation of what came out of the test chip.
Yeah, I mean, I guess I can say that you know, our plan at least is to build a test chip that has this type of bump pattern in it. So, you know, assuming that all that proceeds, there'd be at least one validation of this bump pattern.
So will the test chips will have one slice? I mean, 256, or it'll be 1 terabit?
I thought okay, let's go to that discussion later, because then I think I just want to be the big thing in my head is the test chip will give us data on field implementation, whether we can hit the spec. It'll generate a proof point for value to the end users and semi vendors. And the test chip has to obey everything that says must in the Bose spec, but need not obey anything that's a reference in the Bose spec. Those are the sort of 3 broad guidelines in my head.
Mm-hmm.
And the bump map is a reference in the Bose spec. It's not a must.
Right. Yeah. Wire order is the must. The bump map is just a recommendation.
So my proposal on the table is when the test chip must obey everything that the spec says is a must, and anything which is not a must but a reference in the spec, if to meet the objective of the test chip we need to sort of go a different way, we go a different way.
Yeah, that makes sense.
Anu Namhoon, you guys have been quiet.
Yeah, I agree.
Okay, Halil.
Okay.
So okay, then for the test chip, we have 2 proposals, and I think each of the proposals is picking. I think Elad, you're saying you guys prefer this bump map, and Sid, I think is a Satya, and you guys had this other bump map in mind. I think both are okay. You can either choose to converge or not converge. I think both options are okay on the table.
That will be awesome if they converge, but it doesn't need to be on this meeting, right? Maybe.
Yeah.
Yeah.
But I think the convergence discussion is limited to the test chip. Like if you want a terabit link, what is the best option? And the advantage that I see is if you build 2 test chips, you know, we can actually try and make them interoperate in some fashion.
Just a quick question, guys. So BOW IP built with, and this is a naive question probably, but BOW IP built with proposal 1 bump map and BOW IP built with proposal 2 bump map, can they interoperate?
So as long as the wire order is as long as the wire order is the same and the wire pitch is not too different, as long as the wire order meets the spec and the wire pitch is not very different, then you should be able to interoperate.
Okay, I think we should ensure, because I think just from an ecosystem standpoint and from the end user standpoint, anybody who's going to build a test chip with BOW IP, at least the first variant should be able to interoperate, and we should be able to demonstrate that they interoperate, because otherwise it's going to be kind of a bit of a black mark, right? If people come out with different pieces of IP that can't talk to each other, and the whole point is lost at that point.
Yep.
Right, but so just to be clear, right, like if somebody does the one that requires either 2 layers or even the expanded bump pitch on a single layer, and you try and get it to talk to the one that's on the screen now, it's going to be a mess, right?
Yeah, I agree. Yeah. So interoperability practically is not feasible.
Right.
Because the wire pitch is so different?
No, it's just that, for example, if you're on 2 layers versus 1, right? Like when we talk about signal ordering, you know, the signal ordering, even if it's quote unquote the same, it would either mean that you would have to splay out half of the signals and then fit vias in between the other half to come up from the other layer, or you actually would reinterpret what signal ordering means and then take all the ones on the lower layer, you know, splay them off to one side and get them connected up to their pairs on the other one. And I'm sorry, I'm sort of describing this with words. I'm happy to sketch a picture if that would help.
So
yeah,
I didn't
it's just
understand that there was a proposal to use 2 signal layers.
yeah. One of the proposals was to use 2 signal layers.
Hey,
For one slide?
Satya, do you want to share your screen again? Maybe Ken, if so you happen to have your slides handy, Satya, by any chance?
I have to go in about a minute though.
Okay. But hey, but you know, there are 2 definitions of interoperability, right? The other question is, you know, can they interoperate at a speed slower than Bo 256?
Right.
Which may also be an acceptable option when you have these 2 bump maps. They can interoperate at full line rate, but they interoperate at a lower rate.
It's going to be really bad. Like it's probably, you're probably down at both 64, if not even 32 by that point. Just because the length mismatch is going to be enormous, right? Unless it's literally just one slice. I mean, I should be careful. I'm sure there's a hero experiment somebody could do. And I'm all for, by the way, having people being able to try out, you know, sort of different bump maps and things like that. It's just, I want to make sure that we're cognizant that, you know, that it's going to be logistically very difficult to get those 2 to talk to each other at you know, a reasonable rate.
Okay. And maybe that, so Sid, I think, you know, the only interoperability promise we make in Bo is A mode, not at sort of the optimal line rate. We've also I think the only sort of thing the Bo spec says, look, anything which you claim to be Bo, you have to interoperate at least at the lowest line rate. I get your point. Now, I guess it's up to the implementation teams to figure out which way they want to go. Halil, do you want to get to 1 bump map for the test chip? I kind of like the idea that there's 2 and then you can sort of see which way works better in some sense.
I think it's okay. The only thing is if somehow those two can talk, but that would be good to show. But I don't think it's necessary. I agree.
It's kind of useful.
The complications only come into play if the test chip that doesn't follow the pattern that was kind of shown there on the screen earlier and has some routing difficulties, a lot is talking about. If that chip is targeted to be reused in later systems and marketed as an open chiplet, now you have this somewhat incompatible or compatible with a higher level of difficulty pattern, which that's but it's only gonna be a test chip and live and die in that test chip domain, fine, that's no problem. But if it's gonna have a later life that's intended, it'll just kind of be that thorn in the side for some time with compatibility.
Yeah, it's fair. But in some sense, we sort of laid out Bo to be this flexible thing, and you know, we're seeing some of the downsides of that flexibility. But if that flexibility leads to sort of, you know, in-field data saying, hey, Bo can't have a static bump map across all its data rates. I mean, that's a good thing to know early in Bo's life. That hey, there's only so much of a price.
I want to point out one thing. You know, a lot of this discussion was launched by an assertion that you know, there's a particular type of thing that was better, and I guess, you know, I personally don't agree with that specific statement. So I think it's a very good idea to just, you know, the test chips can do what they need to do. You know, we'll get some real data. and hopefully the real data will point us as to whether that statement is true or not. If it is, then we can plumb that field further, and if it's not, then I think all of our lives are easier anyways.
Yeah, okay, but I guess I'm responding to Javi's point that a test chip is a good way to find out whether the spec needs to be tightened or loosened, and this certainly gives us some.
Right, and again, I think Javi's point was that basically, if the test chip is sort of going to be propagated to take on a life of its own, that's where sort of, you know, there's potentially problems. But if we're just cognizant of, yeah, look, this is a test chip, it's explicitly going to explore this axis of things, and you know, and that data will tell us, you know, the right answer, then I think everything is consistent.
Okay, so we're out of time.
If I interpreted your comment incorrectly.
No, that was spot on.
Great.
So next week, we're going to pick up on just going back to the test chip, what it looks like, and then what kind of a test infrastructure we want to build, and whether there's shareable validation infrastructure, etc. And we're going to decouple. If the test chip effort provides feedback like it did in the checkerboard, then that's great, but we're not going to try to force changes in the both spec. That's my takeaway from today's meeting. And then next week on, we're going to go back to sort of practical discussions around the test chip itself and what forms it should take. Is that fair? Is that a fair summary?
Sounds good to me.
Yeah.
Okay, I'll need to drop off.
Okay, Satya, does that work for you as well?
Yes, sir. Thank you.
All right. Halil, say all right, everyone. Thanks. Bye.
Thank you very much.
Thank you, everybody.
Thank
Bye-bye.
you.